Thanks everybody for showing up. It's my pleasure to introduce our speaker today. John Bell, along with his extended family, runs Elmwood Stock Farm in nearby Scott County. This was a traditional cattle and tobacco farm for many years, and then in the 90s, they began a big program of diversification so that now it's a 550-acre certified organic farm that produces livestock, produce, and numerous other products. And John is in charge of the cattle, pig, and crops programs at Elmwood, as well as keeping track of the rotations, the cover crops, and all of the activities that are used to build soil health. And John is a member of a number of commodity boards and community organizations. He's a board member of OAK, the Organic Association of Kentucky, and the Scott County Extension District Board. I first heard about John from Krista Jacobson, who has had the pleasure of doing studies on Elmwood for many years. And then I first heard John speak at a departmental mini retreat we had a couple of years ago here on campus. And I was really struck by how well he understood all of the different aspects and tenets of his farming operations and how they all tied together, achieving a level of integrated knowledge that all of us field researchers aspire to, but almost never achieve. So that was really impressive to me. So given all of that, and given the fact that organic grains seem to be coming of age in Kentucky, it just seemed like an excellent time to invite John to be part of our seminar program and tell us about his interesting operation in Scott County. So with that, John, welcome to our seminar program. We're delighted to have you. Again, I'm sorry to drag you out of the field on a nice sunny day like this, but you can share your screen, so the floor is yours.
Thanks, Dave. Thanks for setting the bar so low so I can do nothing but succeed after that introduction. I am just thrilled to be talking to you guys about my farm and about farming. For most of, I've been married 18 years. I've got 3 kids in elementary, middle school. So frankly, I don't get off the farm much anymore. And I'm certainly not a social media person, so I don't get to talk farming too often. Most of the time when I'm trying to talk farm around here, the response is, no, Daddy, we don't want to hear about your peck weight planter residue slicers, or, we don't want to hear about your carcass data, Daddy. So my audience isn't as interested as I'm hoping maybe you guys are. So I'm happy to be here. When Dave asked me if I wanted to come spend an afternoon with you guys in the spring to talk about my farm, I was kind of waiting for the catch. And when he assured me there wasn't one, I was like, of course, I'd love to. So I don't know why you guys want to listen, but I'll be glad to talk about it. So we had a really good, Dave gave a great introduction to Elmwood. Let me get started here. I don't know what's happened now. Can you all see that? See anything?
Yeah, we can see the PDF.
You can get it full screen. So I don't see anything there. Do you?
No. So, but the other isn't bad, really. We can.
Yeah, let's just do that.
We can live with that.
Okay. So Elmwood Stock Farm. So kind of what I was hoping to do is today quickly go over where we are, what we do now, a little bit of history of how we got there, but basically our farming rotation practices now. And then introduce kind of what we're evolving, changing, experimenting with, or looking into. I gave a similar talk back in January, the Fruit and Veg Conference and the Oak Conference. So if any of you guys heard me speak then, first off, I'm sorry you decided to come back and hear me again. But the introduction or beginning part is similar, but there is new information here. So hang with me, and I think we'll get to some new stuff. I have quite a few slides. I'm going to try to run through them fairly quickly. Try not to get bogged down on details, and then let your questions steer the conversation at the end. So real quick, Elmwood's 550 acres. Of that, 200 acres is tillable, but we only crop about 75 of those 200 acres every year. And of that 75, roughly half of it is grain that we feed to our livestock, and the other half is produce that we sell predominantly through retail. Almost all of our produce and almost all of our proteins are sold to end consumers within about 70 miles, 75 miles of the farm. We've been certified organic since 2000, and we've practiced this crop livestock rotation for several generations. It was the fundamental tenet that my grandfather taught my dad, who taught us, is you don't just do fence row to fence row crops every year. That you rotate. You let your land rest and you graze it with cattle for a few years, and you put it back into crops. And so that livestock crop rotation has kind of been fundamental to Elmwood, and it's kind of what I want to focus on a little bit today. I feel like that rotation it's key to how the farm operates, and I'll bring it up again later. It's what made transitioning to organic fairly easy for us. So now today, as Dave said, growing up in the 80s and 90s, we were a traditional Central Kentucky cattle and tobacco farm, Burley tobacco. And then cattle, we raised purebred Angus. So we sold breeding bulls and replacement heifers to our neighbors and friends. Basically, as my sister and I, the short answer is, as we graduated from UK, the same footprint needed to support 3 families instead of 1. And so instead of getting more acres, we just diversified. We introduced more enterprises. And it was also, honestly, seeing the handwriting on the wall with tobacco, not wanting to stake our future on tobacco. So we raised our last tobacco crop probably about 5 or 6 years ago. For several years, it was just organic tobacco contract, but still, that was a cash cow. We knew how to do it. So we rode that for a while, but we didn't want to build the future on it. So we started growing produce, wholesale, a little bit of retail through farmers markets. And now about 90% of our produce is by far our largest income source, and 90% of it is sold retail. Proteins, instead of beef cows, now we have pigs. We have about 60 beef cows. They're your weanlings and yearlings that we finish out. We have 2, 3, 4 mama sows. So like last couple of years, we finished 30 to 40 pigs on the farm. We have about 20 to 30 ewes and their offspring. We'll do about a couple hundred turkeys every fall, a few hundred laying hens to sell eggs, and a couple thousand broiler chickens every year. And then we graze a little bit of grain. So that 75 acres of crops, roughly half of it is in corn, soybeans, maybe some cowpeas, and then some type of small grain, usually rye, a little bit of wheat. The other half of the farm and row crops, cash crops, is in produce. We probably grow 50 or 60 different types of fruits and vegetables, mostly vegetables, that we sell retail along with our meats, proteins. So that's the footprint, and that's the marketing where we find ourselves now. So from starting the diversification with wholesale produce, the first thing was pumpkins in the early 90s, and attending a few farmers markets with mixed vegetables, that's where we are today. All of that's built on this crop rotation. Similar rotation that we were taught using tobacco, and we've just replaced tobacco with the other cash crops, grains, and produce crops. So our farm has 350 acres of land that's not flat enough to till, to crop. And we don't do, herbicide applied no-till. We do some no-till, but we don't. We'll get into that at the end of the talk, but our no-till still involves some tillage. So basically, if you can't till the land, we don't cash crop it. So we have, 550 acres, 350 is in permanent pasture for our cattle. 200 acres of cropland, but of that 200 acres, we're only cropping about 75 acres a year. So we divide that 200 acres into 25-acre plots. Every year we're plowing sod, about 25 acres of sod. We'll crop it for 3 years, and then we sow it back down into permanent pasture for 5 years rest. So every year, plow 5 acres, sow down 5 acres, plow 5 acres, sow down 5 acres. So that's our rotation, our crop livestock rotation. While it's in pasture, we have the cattle or the livestock on it as well. So kind of the examples of our typical crop in that rotation. On the vegetable side of the operation, that first year plowed sod is tons of nutrients, tons of soil built up, nitrogen, humus, organic matter, basically a lot of latent energy in that soil and nutrients and biology to make minerals available. So that's where we plant our full season, high value, high yielding potential crops. Vegetables, that's going to be tomatoes, peppers, eggplant, squash, cucumbers, stuff like that. Then we harvest that all summer. This is with no fertilizer. We just turned under this diverse sod, plowed it under, grow all these crops, sow a cover crop. Second year, we'll do our spring and fall transplants, cool season transplants. Third year, that ground is pretty played out. We've mined the nutrients, or at least, especially in nitrogen, we've used a lot of that. There's not a lot of residual nutrients there. So that's where we plant our legumes that are able to generate their own nitrogen. And also sweet potatoes, we have found, does pretty well in less fertile soils. Real quick on the legumes, we've learned kind of, and this applies to the soybeans in the bottom half of this example, if we don't even apply a starter fertilizer, if we plant a legume with inoculant in a really carbonaceous soil. So if you look in that second rotation, first year plow sod, we plant corn. Second year, we want to have we put our cattle on the corn fodder in the winter, but there's still not a cover crop. We disc that corn fodder and disc it in and plant soybeans in that really high carbonaceous material. They don't just jump out of the ground and take off, but if we don't give them any starter fertilizer, and we inoculate them, if we make them work early, they actually yield pretty well. If we kind of help them along early on, then they run out of gas since we're not side dressing or fertilizing them later, and they actually don't yield as well. So whether it's snap beans, green beans, dry beans, or soybeans or cowpeas, that does pretty well in some pretty depleted or high carbon soil, low nitrogen soil. It's worked for us anyway. So yeah, that first year, the vegetable field, a lot of times we follow up that third year vegetable crops with a small grain cover crop, a little bit of fall sown alfalfa and grasses. And if that takes, then we got our 5-year perennial pasture established of grass, alfalfa pasture. Or, the second rotation, we do corn first. In the corn fodder, we do soybeans. And then in the soybean fodder, we'll no-till a small grain. Into that second year, we no-till our rye or wheat. A little bit of grass with that, frost seeds and clover in February or March. And if all that takes, when I combine the small grain off, I got my grass clover pasture established. So that's kind of our basic rotation for the grains or for the vegetables. So after that, it gets 5 years of rest in the pasture. And so what's happening in the 5 years of pasture? So it's the forages, the perennial root in the soil for 5 years, no interruption, no tillage. Might be hibernating on cold days in the winter, but even if the sun's out on a cold winter day, there's a little bit of photosynthesis going on. So we've got, roots growing in the soil. The photosynthesis is pumping sugar water down there. We're building humus, building organic matter, and then all that the root exudates is feeding biology. So all that biology that I've destroyed with the tillage of all those cash crops, the diversity and the numbers are having a chance to regenerate and come back and proliferate. And so it's that perennial uninterrupted 5 years of a green something pumping sunlight and energy down into the soil is kind of what rebuilds the soil. But it's the cattle that basically allow us to do that. And so we can put pigs on pasture, which we do. We can put chickens on pasture. And it's great for the animals. They benefit from the sunshine, the whatever forages they do eat, the insects, or, the pigs eat roots and they eat mice and voles and all kinds of stuff. they benefit from all that, but frankly, they're not making money off of the forage. You know, if there's any benefit to the pasture, it's the feed that I'm running through those animals that they're pooping out the back end. But the animals, the pigs or the chickens, the poultry is benefiting from the pasture, but there's real no pasture benefit from having them there. But the ruminants, we're able to turn ruminants out on that 5 years of resting ground, and they're able to turn that forage, that soil rebuilding process, they're actually able to make us some money. So they can eat that forage, and a little bit they walk off and wait, but the rest of those 2, 3, 4, 5 tons of biomass that was out there when I turned them out, the rest of that is either pooped out the back or trampled into the soil surface, and it's able to become part of the soil profile. You know, the decomposers break it down, and other than the weight they gained, all that biomass is still there, but yet they did gain weight. And so ruminants are able to allow me to economically still make money while I'm resting those fields. So that's kind of how ruminants economically allow me to rest the soils. Mechanically, you know, there's kind of, I say 3 or 4 ways you can graze a ruminant. You can graze an animal on what benefits the animal the most. And so we do that with our finishers. We sell grass finished beef, but it's not a lean, tough product. You know, it's graded choice. And we've had to learn how to graze animals to get them to finish on forages. So a finishing animal, I'm going to manage them on a pasture that's going to benefit the animal. But then other animals, I can either graze them in a manner that's going to maximize forage production, or I can graze them in a manner that's going to maximize soil building. And frankly, we do both. You know, we try to maximize forage production a lot of the time because that's how we make money, and we're trying to be efficient. We do have to pay the bills, but also I'm using that 5 years of pasture to build soil, so I can also, in a certain management way, by a huge impact, brief impact, long recovery, incorporating both carbonaceous mature plants, but also green lush plants with my cow herd, I can kind of mechanically help rebuild the soil with the way I graze the cattle and speed up the process. So what we do at Elmwood to take advantage of this crop rotation and kind of what we've learned. Well, so part of the rotation is cash cropping. So for 3 years, we're able to make, you know, a few $1,000s an acre or tens of thousands of dollars an acre, depending on which the crop is. Also, you know, over the years, we do less and less wholesale and more retail. We do less tobacco, less tons of leaves and more tomatoes or more turnips or more bunches of kale. So basically value adding. I try to put all the grain that I grow through a livestock, through an animal. Some years we'll have some excess grain and I'll sell it, clearly. But ideally, what we're trying to do is we're growing grain. You know, we don't want to have all of our money in the produce basket because it's perishable. So we like to have, you know, some commodities grown, and adds to the diversity in the rotation. But at the same time, I'd much rather sell a few pounds of beef than a few hundred bushel of beans or corn. So literally, the fewer pounds that we ship out of our front gate, it's that much less stuff fertility-wise that we either have to buy and haul in or try to regenerate or regrow on the farm. So we've learned a value add. So it makes it, growing the fertilizer in place is a smaller hurdle, the less nutrients we're letting leave the farm. And then, so we have 350 acres of pasture that's permanent pasture. It's never cropped. It never has a cash crop come off of it. I call that the lazy ground. But we do feed a little bit of hay. The hay can come off of all the fields, the crop fields or the hill fields, but the hay is only fed on the crop fields. So it's a way to move nutrients around. So that hilly ground that's never cash cropped, it does have hay taken off of it, and the hay is moved to some of that ground that's going to be cash cropped at some point. So 350 acres of permanent pasture does supply some nutrients to those 200 acres of cropland. And then finally, we graze ruminants. I say that those 5 years that those cows are out there grazing while the perennials are rebuilding the soil, those cows are making me a few $100s an acre for 5 years. So then I have 3 years of a few $1,000s an acre. I basically say those cows pay me to not buy fertilizer. Those 3 years I'm doing cash cropping. What we don't do is we don't sell hay. My dad used to say selling hay was just like selling sod, only bulkier. So when you're selling hay, you're just hauling your farm out the front gate. I mean, it makes sense. And we've studied, from our experience, it tells us that. But I searched for some research to support it, and it wasn't too hard to find. But the quick synopsis, or the quick best comparison I found, was Dr. John Laurie from University of Missouri had these numbers. But he had a field of so many tons of biomass, and he hauled it off in hay, and the other half he grazed it and walked it off in livestock. And if you hauled the hay off, it was 6 times more phosphorus was removed, 15 times more nitrogen, and 150 times more K. So, I mean, that's just, to me, that clearly states the point of why, try to value add, try not to haul tons out your front gate, and it's that much less that you have to either haul back in the form of fertilizer or grow in place. So we don't buy much fertilizer. We prefer to buy feed or buy hay if we have to buy anything. That way we at least get double duty from those. If it's feed or hay, you get the nutrients through the livestock, and then you get the fertilizer as well. Simply put, why I think this rotation, sorry about the typo there, it's why I think this rotation works for us. Grazing ruminants reduces the cost of resting and rebuilding soils with perennials, and it can speed the process. So basically, it's just the perennials is what's rebuilding the soil, but if you graze ruminants, they can turn those perennials into dollars. It's just hundreds of dollars instead of thousands of dollars. Seems to be working. We've been doing it for generations. Doesn't seem like we're depleting the farm. So 2 or 3 ways I've looked at to try to make sure that we are doing it. So first off, here's just a simple representative soil test from our farm. So first, just looking at it, the pH is 6.6. Clearly, we need to add some sulfur. We're a little deficient on sulfur, but overall, I think that's a representative soil test. The organic matter in this one's 3.24. On average, our organic matter is right around 3. It's 2.8, 2.9, 3.1, 3.2, in just about every field. It kind of hovers around there. We don't, basically, since we quit growing tobacco, which we would use a lot of ammonia nitrate and urea for, before we were organic, since we quit growing tobacco, but even before that, other than tobacco, we just never fertilized a whole lot. Especially, we never fertilized a crop. We've always our approach has been to mineral balance the soils, keep them healthy and biologically active, and let the soil feed the crops. So when I look at this soil test, what we look at is, clearly we're looking for deficiencies, but we hardly look at what it recommends for the next crop. We're looking more at a major deficiency and then mostly mineral balance. So you can have something available, but if something else is super high or toxic, the nutrient, there might be a deficiency of one thing because something else was way too high. So basically mineral balance or ratios. So we look a lot at the base saturation of those items. That one's pretty close. I would like to see the hydrogen a little bit lower. To me, that looks like missed opportunity. I have some bases that should have some nutrients on there, minerals on there that don't. The potassium at 5, I would like to see that 5, 6, 7. The magnesium, 12 to 15. The calcium, 70, 75. That's kind of what I would like. So, the ratio is kind of right, but we are a little low. And because the calcium and magnesium is a little bit low, that's why the hydrogen is a little bit high that's the way I look at it. And clearly you guys are the professionals and probably are just rolling your eyes at the way I look at it. But we've just always been taught to do more of a mineral balancing and let the soil feed the crop rather than actually trying to feed each crop we grow. And that's worked well, given that we grow a lot of different crops. We have, 50 different vegetables in one field. It's hard to feed one basic crop. But anyway, by that fact, by that rotation that we do, the general ballpark of trying to mineral balance rather than feed one type of crop, not ever using a whole lot of fertilizer in general, it made the transition to organic pretty simple for us. So when people become organic farmers, the first thing you realize, the battle we all fight is weeds and insects, and how do we, try to prevent them or control them. And that's what hits you in the face, because you don't have as many tools in your toolbox in terms of applicants to control weeds and insects. But long term, honestly, my experience has been the organic farms that struggle are the ones that don't have a sound fertility program, or the people that go organic but try to do organic farming, especially on a large scale, and still feed the crops basically the way they would a traditional farming approach. Because organic fertility inputs are so slow acting, so bulky, and so expensive per unit. It's hard to just feed your entire corn crop with feather meal or poultry house litter. It's expensive transportation wise. And so for us, so I think it's the fertility is usually the last thing people think about when transitioning to organic, but it's often what ultimately does a lot of people in that aren't successful at it. So fortunately for us, we had never gotten away from the cattle crop rotation that so many farms used to do around here. My dad and grandfather were adamant that that was important, and we fortunately never got away from it, but it made us going organic. It made that big hurdle not quite as high for us. So back on our rotation, I was actually doing a project with Dr. Krista Jacobson, a different project, an energy study, but we were talking about the rotation, and I was, telling her about it, and it seems to be working, but I would really be interested in trying to do some analysis to confirm, what is going on underneath the ground. And, she got in touch with Rebecca McCauley, and they found a grad student who needed a job or needed a project. And they ended up doing a great study on our 5-year rest rotation. So they took soil samples. It was 3 or 4 times of the year during the growing season, spring, summer, and fall. But I think they took 4 samples. And they took the samples from the 5 resting periods. So the field that was the first year, just been sown down, had been cropped for 3 years, and then the field that was getting ready to be plowed back under and turned back into cash crop the next year. So they took soil samples 4 times from those 5 different fields. And then the 5th field was part of that 350-acre permanent pasture. That was the control. Because, if that's in permanent pasture and it's, somewhat mineral balanced, that's kind of the best our soil could be, you would think. It's all it's been is grazed and a little bit of hay, but it should be kind of the pinnacle. And so they took soil samples. They looked at, I think, I'm butchering this study, so if Rebecca's on here, she can straighten it out at the, after I get through butchering it or simplifying it. But my understanding, or my simple version, is
you're doing great, John. Keep going.
Thank you. You're very, very kind. They looked at the carbon, the nitrogen, and the soil biology. And the summary is basically, yes, there was a statistically significant reduction in all 3: carbon, soil nitrogen, and soil biology, both total numbers and diversity, that showed up after 3 years of cash cropping. But then depending on which one of those 3 categories you're looking at, in that 3rd, 4th, and 5th year of rest, all 3 of those metrics were approaching being similar to the permanent pasture, the control. And so basically, the summary message back to me was, yes, more or less, about 4 or 5 year rest period in a perennial pasture seems to be allowing it to get back to full regeneration mode, full fertility, full biological diversity in numbers. So that was comfort in that, kind of put some numbers behind what we felt like we had seen for generations. Finally, real quick, Krista and John Shimrick from University of Georgia did an energy study, which we could spend a lot of time on this, and I'll try to be really quick, but it's really interesting. It's basically interest in how many calories does it take to generate, how many production calories, how many calories of energy do we use to produce 1 calorie of food? The disappointing thing is a lot. We're not very efficient at it. We're mining something somewhere, because for us to feed ourselves, we're burning a whole lot of calories, a lot more than we're generating in terms of calories of food. That was really eye-opening and depressing and everything else to figure out or have be exposed to just by entering this project. But generally speaking, there's been a lot of studies done. The range kind of goes, in general, everything from commercial row cropping, commodities in the supermarket, traditional protein production methods. The range depends anywhere from, we use 10 to 50 calories on average to produce 1 calorie of food in our current production system. So that's a big range, but it's like corn or soybeans might be one extreme, and feedlot beef is really efficient at the other extreme, or vice versa. But the range on stuff in general was 10 to 1 all the way up to 50 to 1. So in this study, they looked at our farm for 2 years, and we documented everything. Labor, it wasn't just how many man hours are out there, but we had to rank whether it was physically taxing work or sitting in the computer work. Recorded fuel, took an inventory of all of our equipment and what it took to create it, and what the salvage recycle value would be if it was turned back into something else. Fertility inputs, fuel inputs, electric inputs, all energy inputs. Then the UK South Farm CSA program did the same thing. And so after 2 years, you can see at the bottom, we were surprisingly still depressing. We still use a lot more energy than we're creating, but relative to like the average production system, or relative to the UK South Farm, we were more efficient. We were 7.5, 8 calories to generate 1. And honestly, a lot of that goes back to that rotation system. We have low fertility inputs, which the South Farm, their biggest numbers, the biggest difference between us and the South Farm is in fertility that they bring in that we don't, and the compost they bring in that we don't. And we don't do either one of those because of that 5 years of rest and having all those ruminants on there. And so you think about, we're replacing hauling in fertilizer, and we're replacing hauling in compost with a cow, and the cow turns out a really high calorie, nutrient dense protein product. So we're not bringing tons of stuff in, and yet we're generating a super high calorie dense food product. So I think that's, that's the big difference between why our system sort of works better than some of the systems. So then we hear, quite often I'm faced with whether it's people talking about organic's great, but you can't feed the world farming that way, or simply not even organic. It's just that your rotation's great, John. I wished I could afford to take some fields out and let them rest, but you can't feed the world if we don't farm fence row to fence row. So I'm really going out on a limb, bringing this back of the envelope math I did 4 or 5 years ago to you guys, because I'm sure you guys will see all kinds of holes in it and what I did wrong. But still, after hearing that, so quite often in preparations for a talk 4 or 5 years ago, back of an envelope, my calculator, and Google, I did a quick figure. And so it could be wrong, but I looked at it again before I brought it up now, and it seems to come out right. But 4 or 5 years ago, roughly, there's 7 billion people in the world, and there's 7 billion arable acres of land in the world. So basically, I just took that. My quick, inappropriate summary is there's an acre of land for every person. So if you prorate, look at what our rotation is. So is our farm representative to the average arable land? I don't know. 200 acres is croppable and 350 is not, that we can't crop. It's pretty fertile, but it's not flat. It's not Iowa farmland, and it's not all irrigated. So I don't know where we stand in terms of natural fertility compared to the average farmland, arable land in the world. But I went with what I know. So if in our rotation of cropland, on 1 acre we grew tomatoes, A second acre, that second year land, we grew kale. In the third year, we grew sweet potatoes. So thinking of a complete diet for somebody, that's a fruit, that's a leafy vegetable, and that's a root high energy vegetable. So I kind of was thinking of a complete well-rounded meal and stuff we grow on the farm. So I have some yield data from. So that's 3 acres. And then 5 acres of rest. So it takes us about 4 acres to have a cow or calf or yearling and a finishing beef on 4 acres. So we get this isn't bought and brought in, this is being born and raised. Roughly, we figure 1 finished beef per 4 acres. That's including the cows and all the generations. So on that 5 acres, that's 1 1/4 finished beeves. But again, our whole farm isn't croppable. So we still have the 350 acres. So the prorated 8 acres in that rotation, the corresponding 22 acres of set aside permanent pasture. So that's a total of 30 acres of land. So on that 22 acres, that's another 3.5 beeves I can finish. So I don't know if all that makes sense or not. It does to me what I did. What it boils down to is using our average yield of tomatoes, kale, and sweet potatoes, and those 3, 4 3/4 beeves, we would produce 1,660 pounds of produce and 103 pounds of beef per person per year. So we're producing more of that, but we're talking about a 30 acre total. So that's for 30 people. So when you divide it back down to a per person basis, it's coming out to be 4.5 pounds of produce and 4.5 ounces of beef per person per day, the way we farm. And on average, people consume 3 to 4 pounds of food a day. So I think it's sort of a well-rounded diet with a little bit of protein, not a whole lot, but some. And so I don't know how I made tons of leaps there. I recognize and acknowledge that. But with that said, I'm not willing to concede that you can't use this rotation, a similar rotation, a rotation of taking cropland and putting some of it back into pasture to let it rejuvenate and rebuild and bringing in less off-farm inputs. I'm not going to concede that you can't feed the world doing that, because we have so many areas of inefficiency that we can improve on. So I know that we could do better as well. That's enough about, that's a summary of where we are, what we're doing. We feel like it's working. We have a little bit of number from you guys that kind of helped ease my anxiety that we're not mining the soil too much. And so, and then the whole back of the envelope figure that I just showed you, that's kind of my comforting myself that, you know, I'm working on something that I'm barking up the wrong tree. I feel like, you know, there's some merit to what we're doing and have done here. And so we're going to continue going down this route or exploring this route. So that's where we are historically. That's what we've done. That's what we're doing. The bulk of what we're doing now is that management practice I just discussed. So what are we doing experimenting? You know, 20 years ago, we weren't organic. 30 years ago, we weren't growing produce. So what are we working on now? First thing, little step, recent step. You know, we have 5 years of all those perennial soils in the ground. It just turns my stomach to hook to a moldboard plow and plow that. You know, I feel like I've taken 4 or 5 steps forward, and as soon as I hook to a plow and turn it, invert 6 inches of soil on its head, I'm taking 3 steps backwards. But it is a perennial pasture, and, you know, we don't have herbicides to take it out of production. So you got to do something to take a perennial alfalfa and bluegrass out of production. But what we've had luck with is we've about 3 years now, you know, we overgraze that into the winter, which is easy to do. You know, you just put your cows out there and let them graze as much as they can. And then we've rototilled it about really shallow, 2 inches deep. That's basically, you know, that's my mechanical version of, you know, gramoxone, burning it off. And it's worked. We don't get well, 3 years, 1 year we darn near got 100% kill, but most of the time we get about 80, 90% kill. But a second and third tillage to actually prepare, just the process of preparing it to put transplants out there, you know, all the sod's dead. So right there, you know, that one huge inversion of destructing event we've replaced with, you know, a shallow 2-inch tillage. So we've been pleased with that. Big picture though, we're practicing, playing around, toying with replacing that 5-year perennials that I've just been telling you all about and how great it is with a tighter rotation of multi-species winter and summer annuals. So if our rotation's working pretty well, why would we consider changing it? Well, first off, again, there's that major significant tillage event that comes as soon as you sow a perennial out there, you're committing yourself to some kind of major tillage event to end it, at least organically, because we don't have a good burn down. Multiple plantings of an annuals offer a chance to green stale seed bed and control weeds. So being organic, again, I don't have as many tools in my toolbox for weed control. So if I'm using stale seed bedding as an effective way to weed control, but I hate to see ground brown for weeks or months on end. It's missed opportunity to capture sunshine, and there's missed opportunity. There's either missed opportunity to build soil, but not even that. The longer there's nothing growing there, the soil's dying, the biology's dying out, we're going in hibernation, you're kind of going backwards. So if you do a series of winter and summer annuals, multi-species annuals, basically you're planting the weeds is a way to look at it, but you're controlling the weeds. And if you don't let them go to seed, even if you're doing a series of annuals with a tillage event to end them and then another annual, we're doing sort of stale seed bedding, but it's green, it's not brown. So the real trick or the real catch or the real question or experiment to answer is, perennials are there for 5 years of slow, they're kind of the turtle, in the race. They're there just always turning sunshine into energy into the soil. They're always growing. They're just slowly plugging along. Annuals are the rabbits. You can put out some annuals and multi-species stuff, and in 90 days, you've got tons and tons of biomass that you can, I'm going to graze it off, but I mean, you can incorporate it, flail mow it, till it in, do something like that. But annuals are, you can turn a lot of stuff a lot faster. So the offset is I'm giving up 5 years of the slow turtle that we know works, but if I do manage the rabbits correctly and they grow fast enough, and I incorporate them through grazing or whatever, grow some more, incorporate those, is that going to be a wash? So that's the question, I guess. And then finally, we do grass finished beef. We don't want it to be, it doesn't have to be lean. It doesn't have to be tough. And annual forages play a big role. We have a series of forage chains for those grass finished animals. So some foragers in the spring have a great energy in the leaves and in the forage and are great for finishing beef, but in the fall, they're not so good. They're putting their energy in the root reserves over winter, and they're not a good finishing forage. And summertime, some things are pretty dormant and low energy, pretty carbonaceous. So we already like annuals, summer annuals and winter annuals for our finishing program for the energy they provide. So introducing more annuals benefits or fits right in with our grass finishing beef program. So what this looks like, what our experiments are. So first, a little bit off base, but that center picture, I just wanted to show you, that's a vegetable field, plastic. That's first year ground. We plowed sod, laid plastic. Most of that plastic mulch with drip tape will have tomatoes and eggplant and peppers. That has onions in it. Onions do really well on highly fertile soil. And the plastic mulch really speeds them up, and the black plastic speeds them up in the spring. So we do a few onions in our first year ground. But what I wanted to show there was even there, our first year ground, where we're cashing in on all those nutrients we've been building up for 5 years. We're cropping the whole field, but as soon as we lay plastic, we turned around and sowed annual rye and some white clover. And then, so we don't keep the balks or the dirt between the plastic tilled or sprayed to keep the weeds away. Instead, we sow cover crop. We sow something to keep the soil alive and to try to capture some energy. We try to build soil any chance we have, and we sow that and then we mow it. So yeah, it's tedious. Somebody's got to, operate a mower there. It probably gets mowed, 3 times in the spring, once in the summer, and once in the fall. 5 or 6 times, 5 times keeps it under control. But they're not driving a cultivating tractor or a spray boom. I mean, it's it's give or take, but we feel like the growing of cover crops, any chance, the less brown we see, the better, I guess is the best way to put it. The field to the left, that's a straight rye cover crop. That was just taken a couple of days ago. That's Dillon rye. At Dave's recommendation, I put out a bunch of Dillon this year. I don't know if he knows he recommended it, but I did. Something he said, and so I put out a bunch of Dillon. Likewise, the right cover crop, that was also taken a few days ago. But that's rye with peas and vetch mixed in as well. And so our new rotation we're playing around with is trying to do a little bit of what's called organic no-till, which starts with a well-prepared, properly timed and planted fall cover crop. And the cover crop is both your nutrient source and, more importantly, your weed suppression. So sort of like a rotation that we could consider now with utilizing a series of winter and summer annuals to grow a cash crop would be a winter annual of winter rye, vetch, peas that we graze in the springtime, then maybe have to till it, depends on, the weed pressure that's in there. But then you sow a series of summer annuals. And we graze those, let them come back, to graze them again. So that is, instead of grazing that perennials, we're grazing winter and summer annuals. And the whole goal, though, or the important part of that, is having the ground prepared in the right time, which is September, to sow these fall cover crops. So that fall rye on the left, or the fall sowing of the winter peas and vetch on the right. God, the goal is, come on, that's an important slide, you guys.
You can just describe it verbally, John, if you need to.
Well, but that was the whole thing. It was the roller crimper and planter to show you why we were doing all that. Huh. So I don't know if, okay, I'll try to describe it. So a roller crimper is a big roller on the front of the tractor. And on that roller, it's literally rolling down this cover crop. So we don't have herbicide to burn it back. We have to roll it. The roller has some edges on it, I guess, welded angle iron or welded edges on it that crimp it. So it's like a smooth roller, except it's got edges to crimp the plants. So in this picture, you can see the rye is headed out, and you see purple blooms, that's the vetch, and you see the peas, white blooms. So if these cover crops are all at anthesis, if they're all in full bloom, they've reached maturity, when you roller crimp it, for the most part, that roller crimping kills them. So the key is, between what we're doing and other no-till guys that are really cover crop intensive, is we have to wait until everything has reached full maturity. So we spend a lot of time trying to find varieties that are going to mature at the same time. But we will roll that down with the roller crimper and use a no-till planter behind it and plant our crop. And so that way, if you think about that, we had maybe a tillage event last August to establish that rye, pea, vetch cover crop, but we terminate it with no tillage. We plant our no-till crop of corn or soybeans in it, harvest that, and then if it's soybeans, so if we do 100% rye, we crimp it in late May, plant soybeans, harvest the soybeans, no-till wheat in that, and then harvest the wheat. We've gone 22, 24 months with no tillage in this no-till organic approach. But it's all built on having that a cover crop established at the right time, and then it's built on the grazing of similar crops. It could be the same crops, but instead of cropping in them, grazing them off in the soil building preceding years. But you can do that more often, because altogether there's way less tillage than there is in our 3-year cropping cycle that we do now. And even though I'm growing this crop that's in the picture right now for the mulch, for its suppressing weeds, the whole reason the peas and vetch are in there, they're providing a bunch of the nitrogen to grow my corn crop, or my pumpkin crop, or my winter squash, or my hard squash that's going to be in there. So we're growing the nutrients in place with this mulch, but we've also done the grazing and sequestering of nutrients with the livestock the preceding year. So the idea is significantly less tillage events altogether when we do have to till, and significantly more biomass production and nitrogen specifically, but nutrient production with these larger, faster growing annuals in the perennials. So that's kind of the experiment that we're fooling with now. So on the left, what you're looking at, that picture, that would be the rye pea vetch that basically, the research done in Pennsylvania and Wisconsin, where a lot of this comes from, they're doing basically 100% vetch. In Pennsylvania, Wisconsin's not, they're doing more of the soybean research, but they're doing basically 100% vetch as their mulch or roll down crop for their corn. I'm doing vetch and peas because peas do well. Theoretically, I have a little more success combining peas, so that might be a little less peas that I have to buy. Peas are less expensive when you do have to buy the seed. And there's some studies that show pea can actually fix more nitrogen than vetch. Some people are also doing crimson clover around here, but then I can't bring myself to not put any rye out there. I put a handful of rye. The peas and vetch kind of break down pretty quickly. So I put a handful of rye. They add structure for the peas and vetch to climb on now. But then also when I roll it down and it's that thick mat all summer, the peas and vetch break down pretty quick, but the rye residue still gives me a few more weeks of weed suppression for the corn. And then, so also in that, we are, on the vegetable farm, we're doing our pumpkins, winter squash, popcorn, sweet corn. One of our many sweet corn plantings we're doing in there. So we're still learning. We don't do all our sweet corn in there. We don't do all our hard squash in there, but we're still learning to make that work. On the right side, basically, so those are rates that we're playing with, but basically for a few years, we were doing this stuff around, I was waiting for the Hessian fly free date. I was waiting until after October to sow it. And we're kind of moving back because a couple of things. One, the peas and vetch actually do really well. Theoretically, we're supposed to be planting them early, but also we've never had overwintering problems. And I think it's because we've been planting our peas and vetch a little bit later than recommended in October. And they're not big going through the winter. And they also have a little bit of rye with them as a nurse crop. But then they just, in the fall and winter, it looks like a rye cover crop. But from this point forward in the spring, just the peas and vetch explode and take over. I'm a little hesitant. I'm afraid if my peas and vetch are planted earlier, they'll be bigger in the fall and they might have more winter kill issues. So that's a fine line. I'm inching backwards there. The flip side, when we're planting just straight rye to do no-tilled soybeans or peas or beans or dry beans or cowpeas or our legumes, we want to plant that just in a straight rye cover crop. And the straight rye cover crops do have better weed suppression overall. But we've learned a little bit on our farm and what we're, some of the researchers around the country are learning. It's more important. The total biomass of the rye is what determines whether you have good weed suppression the following year in your cash crop. And we're learning that earlier planting leads to more fall growth, which leads to more tillering. So tillered, say 5 tons of biomass rye in May is better than a 5-ton biomass in May that was reached by planting twice as many bushels. So if I plant 1.5 bushels of rye, say early September, and I plant 3 bushels of rye in October, they both can have a similar biomass, but that tillered achieved biomass actually is having better weed suppression. I'm not sure why, but it seems to be working better. So we're learning that I need to quit worrying about the Hessian free date and move backwards, basically, is what I'm learning there. I'm so sorry. I'm so disappointed that it's not there. So I think this is my last slide. Yeah. So I wanted to close with a few specialty grains I'm working with some of you guys. So that left picture, that is purple straw wheat. that was taken 2 days yesterday, actually. That's my muck boot out there to give you a perspective on how high it is. That is Jay Ersman from a distillery out of Cincinnati, New Riff Distillery out of Cincinnati. They reached out to us. They had found some seed that Dave Van Sanford had. I don't know if it was something he was supposed to have. He had it hidden under his seat in his truck or something he was working on, but apparently there's not much around. Dave gave me 25 pounds that I sowed. I actually sowed it with my vegetable air drill. That's why it's in 3-row batches, just to make sure I could cultivate it and take care of it. This isn't for the distillery process. This is basically just growing the seed crop. And so when I harvest that, you guys get some of it back, and then the distillery gets some. And if there's any left, I guess I get some. And then I guess it's up to the distillery guy if he wants me to grow a grain crop for him or not. But he was trying to bring back an old heirloom variety that was in short demand or short supply. So there's one of the distillery led pursuits of an old time variety. That second picture, that's Hickory King white meal corn that I grow for Jennifer Gleason up in northeastern Kentucky, Sunflower Sundries. She has a business or a contract with a bakery, but I mean, they make tortilla chips made from Hickory King white organic corn, bagged and packaged. And, she has a lot of small grocery stores and just, distribution system that's set up. She grows a whole bunch herself. That's asked, me for a couple of years now to grow a few. I've just grown 3 acres for her. Hickory King is a really long season corn, which is bad for an organic farmer. We can't plant in April. We don't want to plant an untreated seed in cold, wet soils. So we struggle with the long season corn as it is. And certainly with that roll down system, we can struggle even, because that's even later. So I struggle with it just day length wise, but also it gets really tall. The ears are really high. So about 4 out of 5 years, we have lodging to some degree of an issue. But she asked real nice, so I keep trying. Some years successfully, some years not. In the best years, it yields 60 to 70 bushel an acre. That third picture is Serafino hybrid rye, first hybrid rye I've ever grown. It's part of another project with you guys. I think Chad Lees might be heading it up from UK. Scott Franklin from American Farmland Trust, that's who's kind of organizing it or overseeing it. They reached out. This is not its first year, but it's the first year I've been involved. So got some hybrid rye out there. That was sown with alfalfa and grass on 3rd-year vegetable ground. It looks like there's a bunch of dark green tall areas. It looks like cow piles, places high nitrogen fertility. It's not that. It was a vegetable residue. There's a lot of high carbon, so clearly it's nitrogen deficient. That's why it's so up and down. But it's still, I can't figure out why there's so many green spots. If that's where a decaying summer squash was or what. But it's really consistent throughout the field. It's really interesting. That last picture, that's kind of my own experiment going on. It's kind of hard to see, but that was taken a couple of days ago. But back on this whole roller crimping, no tilling, maturity dates are significant and important to us figuring that out. So I need rye, peas, and vetch that are all going to mature at the same time, since they need to be mature when I crimp them for them to die. But if something's way mature, then I'm knocking the seed off and basically I'm sowing another crop. And if it's immature, like my rye and pea are mature, but my vetch is not, then the vetch is just going to spring back up and keep growing. For soybeans, we're trying to find an earlier and earlier rye so we can plant soybeans in mid-May rather than late May. We tried a rustic, which is an early maturing rye. It is earlier, but it doesn't seem to have, even when you have it's got tall, skinny stems. So I don't know if it's the shape of it, or we are finding out some varieties of rye have different degrees of allelopathy than others, which used to not be important. And now that is of major interest to me in this whole growing my mulch in place cover cropping thing. So maybe the rustic is early and tall, high of biomass, but maybe it doesn't have a lot of allelopathic effect because we had a lot of weeds break through the rustic. And so this year we're growing a bruisey. So that picture on the right, I can see it because I'm looking at it, but if you look at that rye, the top left corner, kind of a triangle piece, it's more lime green, but it's also slightly taller, distinct line. That is a bruisey out of Texas, summer or a warm season, warm climate rye, winter rye. And then the foreground is Gardner winter rye. But that Abruzzi is waist high and heading out 2 days ago in April. So, you know, it was ahead all winter. They were all sown at the same time. I think that was sown April 25th-ish, I believe. I mean, September 25th-ish, I believe. And that Abruzzi's been ahead all winter. So if it was a grazing cover crop, it would have produced a lot more forage. It looked great, but this is for roll down comparison. But it's clearly, you know, it's going to be ready way before the peas and vetch that are with it. But I mean, this was my first attempt at it, and so it's heads and tails ahead of everything else. But so I got Gardner out, I got Dillon out, and then the hybrid. So that's about it for the current special grain projects. Looks like I've talked way too long, so I'm game for questions. But if you guys are finished at 4, I'm sorry I went so long.
No, we're good, John. That was outstanding. Let's everybody show John some reactions, some of these emojis. That was wonderful, man. We already have a few questions in the chat box, so I'm going to go ahead and read those to you. And
That'd be great. I don't have it open right now. Actually, well, go ahead.
No, go ahead.
I was going to quit sharing the screen, but I'll leave it up there in case I need to flip back and look at something. So
okay, sounds good. So Jimmy Henning would like to know, do you bring nutrients onto the farm and in what form?
So yes, but it's primarily the mineral balancing. And so basically it's a lot like liming for pH or liming for calcium. It's rock form, basically. The majority, so we're blessed with high phosphorus soils. So primarily what we have to bring on is sulfate of potash. And it's for the K and for the sulfur. And it's actually, so of all the fertility products out there, sulfate of potash that I bring on as an organic farmer is very similar to what Southern States has right now. The main difference is Southern States might have been prilled to handle better or have a dust agent on it. So a lot of that stuff, you know, is manufactured and made or created or significantly altered or has an acid on it to make it break down quicker. But generally speaking, organic sulfate of potash and traditional sulfate of potash are very similar. I can't just run to Southern States and get it, but it's not too difficult to find. And so what we do literally about as often as we lime, about 6 or 8 years, we need to spread sulfate of potash on our crop fields, and we need to lime our crop fields. And the liming is usually as much for calcium as it is for the pH. So with that, there's very little, you know, like right now I need some sulfur in a couple of fields. You know, I've counted on sulfate of potash to bring that in. A few times I've added some Solubor. So that's something that's organically approved. So, but quite often, you know, soft rock phosphate would be a form of phosphorus if I had to bring it on. But it just has to be mineralized. And so then the soil biology is, you know, I have to rely on it to make something available. It's slower reacting, just like it takes a while for lime to have an impact on your soil. It takes a while for a lot of the mined minerals that we bring on.
Sure. Okay, Lena Jacobs has a question. There's been some work showing that insect pests can identify crop plants more effectively against a dark background provided by bare soil or tilled ground. In the areas you showed where there are growing green plants mowed between crops in black plastic mulch, do you notice any changes in the crop insect pest pressure?
We have a lot of crop insect pest pressure. So so first off, I'll just say that I can't say I notice a difference because we just don't have bare ground anywhere. You know, we sow all of our black plastic has green. I mean, the day we lay it's bare ground, but it quickly starting to get green beside it because we've just always sown a cover crop with it. What we do is we sow a lot, we lay a lot of black plastic. So basically in our rotation, that first year ground, we do some black plastic. Everywhere else that we do mulch, we try to do this living mulch in place, or we don't do mulch. It's tilled dirt fields. So I guess I could compare, a tilled dirt field insect pressure with the black plastic, but we don't really have the same crops in both places. We have crops that we plant on plastic, and then we have crops that are transplanted in bare dirt. So I'm just never really comparing apples to apples.
Sure.
We do lay some silver reflective plastic, specifically for onions, and a little bit of kale. There seems to be some insects, flea beetles, onion maggot. There's some research, some disagreement, but some of those colored mulches, there's some colored mulches that can like make tomatoes ripen quicker, but there's also some colored mulches, specifically that silver reflective mulch, that confuses insects and helps to keep some susceptible plants clean of those insects or reduce the pressure there.
Okay, neat. All right, and Lucas has a question. Among the soil analyses you did, which analysis is not included in the regular soil test, but reflected your soil fertility? For example, you showed microbial respiration, but I'm curious about any other potential soil tests that you have done.
So the only soil test I have done is like the regular waters lab that I showed.
Right.
And then the one soil test that involved researchers is the one that Rebecca and Krista were involved with. So that's really it.
Okay.
I have sent soil tests to other labs. Honestly, for the way we farm and the way I look at soil tests, the one problem I have, there's a lot of soil that's accounted, that is available in the biology in your soil, and there's not many good soil tests out there that account for that. There was a sweeps out that I sent some tests to in Australia and New Zealand. It's a pretty expensive investment. I've done it once or twice, and they're still they just have a profile that they an algorithm that they use to figure what the soil biology is and what that should be made available. But most soil tests, we all know measuring nitrogen's tough anyway, but therefore most of us err on the side of we don't know what's there, so let's apply some. I'm the flip side. I know it's there and I know I can grow some too. So I'm probably nitrogen deficient on some stuff because I'm kind of stubborn about, I don't need to apply that stuff. I'm going to try to grow as much as I can, both literally grabbing nitrogen out of the air with legumes, but also recognizing soil biology, as tiny as it is, it's still an animal, and animals are amino acids and proteins, and when they die, there's going to be nitrogen available to feed a plant. So that's the soil test I'm looking for as much as anything, is one that can kind of give a little bit of a nitrogen credit from either the latent in legume generated in and or the soil biology that's in the soil profile. That's what's not there. So I'm like everybody else. The only way I'm really testing that is, and I don't do it often, but when I do it, is have some crops with no N and then apply some organic nitrogen, to the little test plot beside it and see how big the difference the yield response is. Krista, Rebecca's soil analysis study, actually Krista did, I take that back. She does have another one that was, let me see. No, they do have another one they did. I don't have it in here. They harvested like bell peppers, beets, and something else and compared it to theirs. And I'm sorry, I don't have those numbers fresh in my mind, but it did, the takeaway from me there was I was losing some nutrients between that first and second year. So I plowed sod, growing crops, but it was important for me to quickly get that cover crop established and or do some intercropping or relay cropping because I needed to tie up or capture some more available nutrients after that first year. In other words, my tilling the whole field up and then sowing a cover crop late into the fall, I was losing some potential nutrients there that they were able to detect in that soil study. And I don't remember if Rebecca was part of that or not. If she was, maybe she could speak to it. But that was another soil analysis that Krista had done out here.
Okay, I was wondering, John, I think you said that almost all of the grain that you produce, you feed on the farm, but so do you feel like is there a solid market for organic feed? Is it a growing market? Is it anything that you've been tempted to pursue?
Yes, there is. The short answer is right now organic grain prices are down. But the big picture is organic grain, they're down because there's a whole lot of organic grain being imported in the United States. So organic dairies are by far the single largest user. And then there's all the organic eggs and the organic poultry business. Those are using almost all of it. And we are a net importer of organic grain, which is very frustrating. And the thing is, that in and of itself, in the organic industry, that's frustrating that we're first a grain importer, and second, that so much of it is, and it's driving the price down because the integrity and is it all organic? There's a real concern or question because it's pretty easy. And it's honestly, if I'm a USDA inspector, I'm going to be more worried about direct human food before I start checking something that far down the line. I'm sure that, I don't know if they look at it that way, but clearly in an enforcement organism that's way understaffed, organic grain that's going to go to a chicken or dairy facility is probably low on their priority. And so that's the answer is we're importing a whole lot. So clearly there's a market for local, but because we're importing a whole lot, the price this year is not as good as it was a few years ago. And like everything, it goes up and down. Ballpark though, it's been several years, but I just figure organic soybeans are $20 to $25 and organic corn is $9 to $10. So the back on that slide earlier, it said on the slide, I didn't bring it up, but under our regular practice, so I have 5 years of rest, I plow sod, plant corn, organic corn. I'm averaging about 125, 130 bushels an acre, which isn't great. My neighbors are doing probably 175, maybe 200, I don't know. But that's with all I have is fuel and my corn seed input. I have no other expense in that whatsoever. And then if that corn's selling for, $8, $9, $10 a bushel, which the average is that it might be $7 or $8. I haven't even looked lately, but that's, it's down a little bit right now. But over the years, it's averaged $8, $9, $10 a bushel, 130 bushel. I'm clearing nearly $1,000 an acre right there. And that's, I can burn that $1,000 pretty fast hauling in some poultry litter to try to get 150 bushel an acre.
Definitely.
I have to haul it so far and it's so bulky, and a semi load does 10 foot, to get the units I want. So that's kind of what we're looking at, I guess, in the organic industry side.
Yeah. Okay, thank you. All right, any other questions for John before we let him get back to his day job?
I would like to say, now that there's more people on here, I brought it up earlier, but we are hiring. So if anybody's got some students graduating looking for some farm work, it's posted elmwoodstockfarm.com. So my last slide that's also white is our website, Elmwood Stock Farm, ELMWOODSTOCKFARM.com is the website. So contact us is on there. But we have a couple of jobs open. It's production. Often we're hiring packing shed or order fulfillment or, delivery drivers, but this year it's more production related. We're looking for somebody to drive a tractor, pushing a cultivator or tilling some of this ground that I need to resow in pastures right now. I need a tractor driver. And then we also have, a little bit of handwork in the vegetable leafy green intensive production, sowing kales and lettuces and salad greens and stuff. So anybody has some students or family or friends looking for, we're looking for full-time year-round for both positions.
Okay,
Take part-time for the summer at this point, whatever we can get, but we're
sure.
looking.
Okay, we'll keep our eyes peeled.
Thanks.
John, thank you again, man. That was outstanding. Really appreciate it.
Thanks everybody for your time. I appreciate
Thanks
it.
everybody for showing up. Everybody have a good weekend.
Thank you, John.
You're welcome.
Thanks so much, John.
Thank you.